Hello, and welcome to the Usefulati, the show that turns the writing of the world's most useful people into audio episodes you can listen to on your drive to work. Today we have a blog from Casey Handmer, the founder and CEO of Terraform Industries, a startup that's turning water and air into carbon-neutral natural gas with solar power. See the description for more, and let's jump in.
For years ago, unable to find a comprehensive summary of the ongoing abject failure known as the NASA Space Launch System, I wrote one. If you're unfamiliar with the topic, you should read it first. It is hard to believe 4 years have gone by, but in all that time, the Space Launch System has launched only once. Time flies when the rocket doesn't. I don't often write blogs in a sharply critical tone, so as always, the usual disclaimers apply. I write in my personal capacity as some guy with an opinion on the internet. 4 years ago, I wrote that the Space Launch System was a cripplingly embarrassing national failure and a tragedy waiting to happen. That remains true, of course, but now I will go further and underscore that by continuing to humor this monstrosity, NASA has squandered its technical integrity and credibility. In ways that are far clearer to me now, after 3 years of running my own budget and schedule-constrained hardware technology development program, I have more insight into the structural issues that evidently underlie every part of the Space Launch System program. NASA managers routinely complain of difficulties in hiring and retention, difficulties they never faced 20 years ago, before the Space Launch System and before the private space companies that, unlike NASA, are able to offer some combination of market-rate compensation, a career track that rewards ambition and competence, and a workplace that swiftly departs underperformers. Just imagine the mental agility required to actually want to work for an agency that continues to insist on technical doctrine no less absurd than 2 + 2 = 5 from top to bottom, from onboarding documentation all the way up to press releases, bilateral agreements, and policy papers. Everyone at NASA knows the Space Launch System is a looming catastrophe, but no one can say it. Officially, it's still the most powerful rocket ever built, except for Starship, and our official vehicle to the Moon and Mars. In reality, it's insanely expensive, dangerous, and underpowered and can barely lift a reasonable payload to low Earth orbit. 4 years ago, I wrote that the best time to cancel the Space Launch System was 20 years before, and the second best time was then. 4 years on, the program has consumed another $20 billion with nothing to show for it. $20 billion, bringing total development cost to over $100 billion. This program burns $12 million per day. In the meantime, NASA has abandoned all pretense of caring about or delivering cost control on any major project, with scope, schedule, and budget blowouts affecting practically every major program and forcing the cancellation of many of them. This is symptomatic of an agency who, compromising their technical integrity on their flagship program, subsequently lost the ability to maintain technical integrity anywhere else. A reader reminded me that Congress reauthorized the Space Launch System just a week before this post was published. I don't want to preempt the results of the study due in late March, but I will register here that I believe the answers are, there is zero demand for the Space Launch System by any non-NASA entity, and this has been abundantly clear since no later than the first flight of Falcon Heavy in 2016. Space Launch System development has consumed nearly $50 billion since then. There are no cost and schedule savings from reduced transit times or increased returns enabled by the unique capabilities of the Space Launch System, since the only attributes unique to the Space Launch System are strictly negative. Barriers or challenges to use of the Space Launch System by entities other than NASA, primarily the legal operation of any other launch vehicle. NASA's progress towards achieving the flight rate is strictly negative, with the schedule slipping approximately 1 year per year. Mars Perseverance, a supposedly cheaper built-to-print replica of the Curiosity Mars rover from 2012 then required extensive re-engineering costing $2.4 billion, the same as the previous rover. At least it didn't cost more. Meanwhile, much of its instrument payload was consumed by a sample handling system for a sample return mission that, at this rate, will never occur. Mars sample returns budget grew from $1.6 billion to $11 billion while the schedule slipped multiple years to the right. Somewhat beyond the scope of this post, I wrote another already, but worth pointing out that various elements within NASA assumed that it had grown too important to fail and acted accordingly, and while it was staffed up with dozens of strategy interfacing managers across a bunch of centers, they still hadn't closed basic architectural trades on a project that had been studied since the 1970s. This fundamental failure of project discipline is reflective of the broader problem. An agency tasked to execute the most challenging technical projects has lost its way in the wake of the ongoing Space Launch System debacle. As of September 2024, Mars Sample Return has already spent $3 billion before being paused indefinitely, while mostly the same people who caused this problem try to figure out how to solve it. Veritas' mission to Venus indefinitely postponed due to budget constraints. Space Launch System, like the James Webb Space Telescope before it, eats everything in its path. Meanwhile, NASA hasn't sent a single mission to Venus since 1989. Habitable Worlds Observatory and the New Decadal Survey. The James Webb Space Telescope, originally budgeted in 1999 for $1 billion to launch in 2007, ultimately launched in 2021 after spending $10 billion, so horrendously late and over budget that instead of reimposing any kind of programmatic discipline or inventing a contract structure that doesn't reward Northrop Grumman for wasting money, NASA instead has decided to delay the next big space telescope, currently termed the Habitable Worlds Observatory, into the 2050s. This may as well be forever, given that every human currently alive who knows anything about building space telescopes will be retired by then. Dragonfly, a super cool nuclear-powered robotic octocopter to explore Titan, was originally budgeted at $850 million and is now pushing well beyond flagship status at $3.35 billion. How is it possible to miss this badly? Is budget estimation just some fig leaf used at NASA to push the favored mission over the selection line, and then another set of books is used to actually build and run the mission? Are any of the program managers personally incentivized to innovate, improve productivity, or control cost? Viper, a robotic moon rover at the South Pole. Originally conceived as the Resource Prospector rover from NASA Ames, then cancelled in 2018 after spending $100 million on development, the concept returned as Viper. Its budget grew from $250 million to $450 million and most recently to $685 million, exceeding a critical cost cap leading to cancellation despite being a supposedly essential part of Project Artemis. It has completed assembly and environmental testing, but will now be scrapped instead of launching on the New Griffin commercial lunar lander, which will instead fly with a mass simulator. Psyche, a mission to a metal asteroid. It missed its launch window due to a software issue discovered during final checkout, growing its budget from $1 billion to $1.2 billion and pushing Veritas into limbo. How did this happen? They completed flight hardware and shipped it to the Cape but had skipped an integrated testbed test prior to assembly. When this was performed, it was discovered that an aspect of the hardware design prevented the navigation software from working properly. Engineering a workaround took months, adding $200 million to the budget. NEO Surveyor. In 1998, Congress mandated that NASA map 90% of near-Earth objects larger than 1 kilometer, asteroids capable of destroying our entire civilization. Now, 30 years later, the mission has been pushed back another 2 years despite an increased budget, now expected to top $1.2 billion. The official line is that despite this delay overall costing more money, it saves money from the budget in the short term. Meanwhile, NASA's mission to study existential risks to all of humanity? Shrug. Europa Clipper. Budget grew from $2 billion in 2013 to $5.2 billion. One instrument, the IceMag magnetometer, was cancelled due to poor progress. This instrument's technology had been built and flown before, but the necessary expertise was lost due to retirements and an achingly low flight rate. During final testing before launch in a few weeks, a known problem with radiation-sensitive MOSFETs was rediscovered. Known, as in this problem was flagged as a blocker at about 5 different design reviews over the last decade, but for whatever reason, perhaps sunk costs, was ignored and pushed to the next phase. Well, now the mission is integrated with Falcon Heavy and ready to launch. I sure hope it works properly when it gets to Jupiter. Ingenuity developed for less than $25 million because JPL was spending its own money. The little helicopter was, like Sojourner, a business development tech demonstrator and, in the event, a formidable asset for Perseverance until it crashed on its 72nd flight. But instead of learning something about NASA centers rediscovering cost discipline when it's their own money on the line, it's now 5 years later and much of the talent that built it has moved on, with follow-on Mars helicopters stuck in endless studies. CASIS, the ISS National Lab. In an effort to defray costs and prolong the life of the station, NASA spent years building CASIS, an independent nonprofit, and the ISS National Lab to find private customers. At just $4 million per person per day, perhaps we shouldn't be surprised that industry didn't overwhelm them with attention, spending $75 million to stimulate $150 million of revenue against an ISS annual budget of $3 billion. Its record was further tarnished by Charles Resnick, the chief economist on the project, expensing prostitutes. Chandra X-ray Observatory, already launched and operating in space, is being defunded with 10 years of operational life remaining because of budgetary pressures. Block 1B and the exploration upper stage. Yet another configuration of the Space Launch System with a beefier upper stage, but only a marginal increase of launch capacity. Costs billions, a decade behind schedule, and provides no additional capability not already obtainable from commercial launch providers. Artemis spacesuit provider Collins backs out. For a program that's been in development for almost a quarter of a century, it is a constant unpleasant surprise to find that critical complex pieces of machinery, in this case, spacesuits, are left to the last minute then farmed out to contractors. Collins, who once built spacesuits for Shuttle and Apollo, won a contract after NASA's internal suit development program burned through $1 billion with nothing to show for it. After spending more than $100 million, Collins realized they had no path to success and asked to abandon the contract. NASA complied. NASA wisely also commissioned spacesuits from another commercial contractor, Axiom Space, except Artemis spacesuit provider Axiom Space in trouble. Axiom, one of several commercial entities attempting to build space stations, boasted an all-star team drawn from NASA's Johnson Space Center, plus a bunch of plump contracts for development. Starting in 2016, the CEO, former NASA official Mike Suffredini, staffed up 800 engineers and by 2023 was struggling to meet payroll. What's the plan now? Land on the moon but don't go outside? At the same time, SpaceX has developed their own suits, including a recent EVA-capable version used on Paul Arry's Dawn. Does anyone else see which way the wind is blowing? I haven't forgotten Gateway and Starliner, they get a full treatment below. All these projects are pretty cool. All these projects should have been built and launched years ago. All these projects inexplicably take far longer and cost far more than they should, and no one ever seems to drill into the why and how and let's fix it. NASA's leadership has not risen to the challenge, and why would they? While NASA HQ has thoroughly mismanaged Mars sample return, according to the Independent Review Board, they are yet to return to in-person office work post-COVID, resulting in much of their DC office building being leased to other tenants. I don't know about you, but if my space agency officials were so unable to do their jobs that half their missions were cancelled and the other half delayed, I don't think I'd assume that staying remote would fix that problem. For years ago, I wrote about fixing this situation. The required organizational transition is equivalent in scope and difficulty to the Apollo program, and will be made or broken during the tenure of the next NASA administrator. This obviously has not occurred. As we inch toward the end of the Biden administration, and without any particular insights into how Trump or Harris would change space policy, it pains me to say that Administrator Senator Nelson has not risen to this challenge. Aside from pushing Kathy Ludders out after she awarded Human Landing System to SpaceX, we have little to show for 4 years of work across the agency. After I published my previous post on the Space Launch System, a number of NASA insiders called me over the following months to express profound pessimism that any kind of organizational transition or improvement could possibly occur. At the time I was optimistic, now I am not. Indeed, if we ignore SpaceX's continuing achievements in launch, cargo and Crew Dragon, Starship, and Starlink, NASA's ability to run its programs have never been weaker. But for SpaceX, we would still depend on Russia for dodgy Soyuz launches to station, even as Russia continues its lawless rampage in Europe. But for SpaceX, both the US and Europe would lack adequate strategic access to space. But for SpaceX, Artemis would stand zero chance of success. Not only has no one responsible for the Space Launch System side of the Artemis program introduced the barest modicum of accountability, if anything the situation has gotten far worse. NASA has spent $20 billion on the Space Launch System and related programs in the last 4 years, so let's tick off updates since my previous blog on this topic. $20 billion should buy a lot of progress, but if anything, this program is even further from any semblance of functionality than it was back then. NASA finally worked out how much each launch actually costs, and it's even more than we thought. 4 years ago, I wrote, remember, even if it actually was fast and safe to reuse shuttle hardware, even if the program was well managed, it would still only manage a Space Launch System flight every year or two and cost between $2 billion and $3 billion per flight. Maybe more. Actually, no one knows for sure. Can you stop asking? Even the people whose only job is to know exactly how much the Space Launch System costs apparently do not know. By March 2022, we learned during a House Science Committee hearing from NASA Office of Inspector General Paul Martin that the marginal launch cost for each of the first 4 Artemis Space Launch System launches will be $4.1 billion. This doesn't include any development costs, which will total $93 billion by 2025. Incredible! Since this report came out, the Space Launch System launch schedule has slipped roughly 2 to 1, so it's safe to assume that the marginal launch cost has doubled since then. How could we know? It was after this embarrassing reveal that NASA tried and failed to sell the Department of Defense on a cost-sharing program, because the Department of Defense hates the Space Launch System even more than I do. 4 years ago, I wrote, I'm 100% okay with Congress cutting generous checks to politically important constituencies to develop hardware for human space exploration, but maybe, just maybe we should have worked out where we were going and what we were going to do there first. Can we now act surprised that the Space Launch System is, at best, an incandescently expensive turkey that's not much use to anyone? Last year, we got an update from Joey Roulette at Reuters with brutal quotes from the Department of Defense after NASA floated cost-sharing to help reduce Space Launch System fixed costs. Shuttle itself collaborated with the Department of Defense back in the 1970s to garner enough funding to complete development, resulting in a bunch of design compromises that significantly decreased its safety and utility. Still, perhaps Space Launch System managers retain some hope. It's a capability right now that we, the Department of Defense, don't need, Colonel Douglas Pentecost, a senior rocket acquisition official with the U.S. Military Space Force, said in an interview. We have the capability that we need at the affordability price that we have, so we're not that interested in some partnership with NASA on the Space Launch System. I don't see the cost going down at this point to be competitive, just given the history and how challenging of a rocket it is to build, said Christina Chaplin, former Assistant Director of the Government Accountability Office, the investigative arm of the U.S. Congress. Even when they stabilize production, I don't see them having quite the factory line that you need to get for that kind of thing, added Chaplin, who led Government Accountability Office audits of the Space Launch System. If they can sell it, they, Boeing and Northrop, get more flow through the factory, that drives down our recurring engineering cost, Jim Free, head of NASA's Space Exploration Wing overseeing the Artemis program, said in an interview. We've thought of a map to get there, we need them to engage, to agree with that map. Convincing about 400 suppliers across 46 U.S. states, already struggling with rising labor costs, to increase production and staffing would be another issue, according to Amit Kshatriya, the head of NASA's new Moon to Mars office, formed in March to manage the agency's Artemis and Space Launch System strategy. Even if Boeing and Northrop do not achieve NASA's cost-cutting goals, the agency still plans to pressure them on reducing costs, Kshatriya said. We can't just wait and hope that all these answers come as a part of this one procurement, Kshatriya added. Just go ask GPT-4 to script the conversation between NASA's bloated and hapless program management offices trying to figure out how to shave cost from the Space Launch System after 2 decades of their predecessors aggressively locking in the highest possible costs and lowest possible production rate. Jim Free, faced with this improbably catastrophic program, responded by cobbling together a few PowerPoint slides begging Boeing to charge less, yet strangely they're unreceptive, probably too busy panicking after yet another excruciatingly embarrassing Starliner failure. It wasn't the last. Why doesn't the Department of Defense want the Space Launch System? It's 30 times too expensive, totally unavailable, and by the way, the solid boosters shake the crap out of any payload you put on it. What's not to love? I'm impressed by the degree of wishful thinking required to convince yourself that A, anyone wants the Space Launch System voluntarily even at half price, B, doubling production rate would halve fixed costs, C, $1 billion per year of fixed costs is even comprehensible, and D, Boeing is going to have a cushy sinecure for you in a few years, too. As of 2024, Jim is still the Associate Administrator at NASA. At the time of Roulette's article, Kshatriya had just been promoted from Assistant Deputy Associate Administrator for Exploration Systems Development to Deputy Associate Administrator for Moon to Mars program, becoming Jim's number 2. They've been working this problem for 3 years now, surely long enough to see that success is not in the set of possible outcomes. At what point will they have the fortitude to report this obvious truth up the chain? Aerojet managed to turn 10 times the purchase price for the Space Launch System engines, which NASA already owns. As of 2020, Aerojet officially earned $146 million per Space Shuttle main engine that NASA already paid to develop and build and already had in a warehouse leftover from the shuttle program. For reference, that's more than the entire purchase price of a Falcon Heavy. Per engine. In 2023, we learned that despite Aerojet being paid $2.1 billion to recondition 16 of these engines for the Space Launch System, by the end of the contract in 2020 they had delivered only 5. NASA's inability to get a refund for these nonsense services already bought and paid for brought the taxpayers' cost to repurchase Space Launch System engines to over $420 million per engine. Once again, these are engines that NASA already owned, and that cost only $40 million each to build in the first place. Not that that's a good price. SpaceX currently builds the far more advanced Raptor engine for under $1 million each, and launches the entire Falcon 9 rocket for less than $20 million. Why is NASA giving $2.1 billion to a private corporation to fail to perform unneeded services on inappropriate engines for a rocket no one wants? Just to hammer this point home, we'll calculate the size of Aerojet's nonsense grift in terms of Falcon 9 launches. For the price of one Space Shuttle main engine, built new back in 2000 in $2024, SpaceX can launch 3 Falcons. For the newly updated reconditioning price, SpaceX can launch 21 Falcons, which is enough to relaunch the entire International Space Station from scratch. For the entire value of Aerojet's $2.1 billion contract, SpaceX can launch 105 Falcons, which is enough to max out SpaceX's current, 2024, considerable launch capacity for more than a year. If NASA is in the business of launching missions to space, why is it giving 10% of its entire annual budget to a contractor only for engines that it already owns? In 2019, NASA awarded Bechtel a contract to deliver a launch tower, a glorified steel truss far simpler than the booster-catching tower SpaceX assembles in weeks, by March 2023 for a total cost of $383 million. As of today, the Office of Inspector General reports that the tower will cost $2.7 billion and is to be finished by September 2027, but more likely 2029. For reference, the Burj Khalifa is 7 times taller, contains paying tenants, hotels, and shops, and was built in 5 years for just $1.5 billion. If you had $2.7 billion in $27,100 notes, and you piled them up, they would be so much taller than Bechtel's non-existent launch tower that you'd need not 1, not 2, but 23 separate piles to exhaust the supply. Whoever wrote Bechtel's side of the contract certainly earned their bonus. Whoever wrote NASA's side should be made to paint the entire structure with a toothbrush, but I expect they've long since been on Bechtel's payroll in some kind of advisory no-show job. The Orion capsule, which has also burned through tens of billions of dollars over 2 decades of development and flown in flight configuration exactly 1 time, uses an old and extremely expensive heat shield technology due to its supposed reliability. After the test flight in November 2022, almost 2 years after the botched Space Launch System green run test, you'll never guess what happened. The heat shield failed in scary and unpredicted ways. NASA is a publicly funded agency and its information is meant to be publicly available. Despite multiple Freedom of Information Act requests, NASA successfully hid this embarrassing information from the public for nearly another 2 years, before eventually some photos of the damaged heat shield leaked out. It should be noted that this failure was not unexpected and had been predicted since the material selection in 2009, but NASA management continued, and continues, to kick the can down the road. There's a reason that other capsule programs admittance test the heat shield early in development and then freeze the design. It's much cheaper to fix problems before the rest of the system is finalized. NASA faces a tough choice here. They've already spent 2 years in deliberations, so perhaps with a few more years of deliberations they can concoct some justification for the failure and sign off on the next flight, which is meant to have living humans on board. NASA has a storied history of moving its pen in just this way, resulting in the loss of shuttles Challenger and Columbia and 14 astronauts. Or, they can go back to the contractor Lockheed Martin and ask them to restart development of the entire capsule with a different heat shield material, such as SpaceX's proven Piker X. This will delay the capsule for many more years and cost billions more dollars. Or, recognizing that even if Orion had worked flawlessly, it's still too heavy and too expensive to do anything useful, so cancel it. Success has never been in the set of possible outcomes, so remind me why we continue to burn billions of dollars on this program every year. NASA is keeping their deliberations on the heat shield a secret. NASA decides to fly the Artemis II heat shield as is, saying A, modifying the re-entry profile should mitigate the risk, B, their review board agreed unanimously on this course of action, and C, the flight will be delayed another 8 months, $3 billion of runway, to 2026. However, additional reporting revealed that the heat shield design was modified since Artemis I to make ultrasound verification of the hull shield bond easier, inadvertently accentuating the design flaw which prevents exhaled gases from diffusing out of the shield, leading to cracking and spalling. Additionally, Charlie Kamada, a retired astronaut who specialized in heat shields, stated that there were at least 2 dissenting voices on the review board. To me, this looks like NASA spent nearly 3 years manufacturing a technical justification to do exactly what they wanted to do anyway. Starliner isn't part of the Space Launch System program, but like the Space Launch System it's also built by Boeing and managed by NASA, and like the Space Launch System it's also fabulously expensive and inexplicably defective. So let's dig in. In September 2014, NASA awarded Boeing $4.2 billion and SpaceX, somewhat grudgingly, $2.6 billion to develop capsules to transport people to and from the International Space Station. The shuttle's last flight was in 2011, so this process came a bit late and resulted in nearly a decade of dependency on Roscosmos for crew transport. SpaceX's Crew Dragon capsule first flew in 2019 and in 2020 brought astronauts to and from the space station. As of September 2024, it's flown 13 flights, 3 private, to the International Space Station, 2 other private flights including the highest ever Earth orbit and first private spacewalk, and carried 54 people in space. In contrast, Boeing's Starliner only flew 2 astronauts to the International Space Station, after 2 previous launches with a series of failures and near misses. Despite being a much simpler design than Crew Dragon, Starliner has suffered from a set of critical software failures during its first flight, in which untested software outsourced to foreign developers both failed to obtain accurate clock information from the launch vehicle, and also incorrectly mapped thruster and inertial coordinate systems, essentially reading the wrong map upside down. As a result, this uncrewed mission burned through all its propellant and was unable to dock with the station. Boeing was compelled to refly the mission. A set of parachute failures, including both crashes during testing and later, the discovery mere weeks before the first crewed launch that critical clips had not been closed before being obscured behind an uninspectable flap. In other words, had this chance discovery not been made and the mission flown with astronauts, the parachutes would have opened and pulled away from the capsule, which would have then plummeted into the ground, killing everyone. The wiring harnesses were wrapped with flammable tape, requiring a difficult replacement operation. The thrusters suffered failures on all 3 flights, due to incorrect thermal environment data being provided to the subcontractor, overheating, helium leaks and seal failures. The subcontractor? Aerojet Rocketdyne. I'm beginning to sense a pattern here. Unlike the Space Launch System and Orion, however, Starliner was developed under a fixed-price contract, Boeing's first and last, resulting in net losses to Boeing of $1.6 billion so far, enough to build another whole Burj Khalifa. Conway's law explains that product structure mirrors the organizational structure that built it. The dysfunction of Boeing's Starliner development program is plain for everyone to see in the achingly embarrassing ongoing failures of the physical hardware. The software failures show that the thruster teams didn't talk to the structural teams and the guidance, navigation, and control teams. The thruster failures show that the systems engineers didn't talk to the subcontractors and mission designers. The parachute failures showed that process safety engineering was nowhere near close-out operations. The wiring harness issue shows that NASA's requirements oversight team were not functioning as a team and not conducting oversight, and likely never conducted a thorough in-person physical inspection of the actual flight hardware. I mentioned Starliner had flown 2 astronauts, Butch and Suni, to the space station. Once on station, the recurring thruster faults were so severe that NASA decided, over strident objections from Boeing officials, that it was safer to strand the astronauts there for a few weeks until SpaceX Crew 9 arrived, than to roll the dice and return to Earth as originally planned. In the end, Starliner made an uneventful autonomous landing, but the ultimate cause of the thruster faults remains unclear since the Starliner service module burns up on re-entry. Recently, it was reported that NASA's Office of Inspector General is taking a closer look at the commercial crew program in the wake of this continuing failure. I, for one, have questions about why NASA signed off on launching people to space in this turkey of a space capsule to begin with. In the wake of this failure, Boeing has fired Theodore Colbert, the head of its Space and Defense Unit. I doubt one firing will be enough. I don't mean to be excessively cruel to Boeing, especially as they continue to lose market share to Airbus after killing 346 people with, you guessed it, untested outsourced software on the 737 MAX, but I think it's fair to say that the organization has overestimated their competence of late. It's quite something to expect to take the NASA Commercial Crew Program sole source. This will be easy, we've done it before, to losing money while spending twice as much as the upstart competitor and still not have a functional product that NASA can use. Boeing has been trying to cancel Starliner for years, but for once NASA wrote a contract that doesn't, directly, at least, hang their contractors' failures on the US taxpayer. In the context of not one, but 2 Boeing whistleblowers mysteriously killing themselves, I will say for the record that I am not now, nor have I ever been suicidal. NASA, too, is complicit in this failure. NASA's officials, astronauts, and engineers oversee their contractors' work and are paid to ensure that programs stay on track. It has been reported that Boeing was quite hostile to outside input, but even so, that doesn't absolve NASA of responsibility. Starliner's ongoing avalanche of failure reflects just as poorly on NASA as the Space Launch System and Orion. Earlier this year, a post from Idle Words on the lunacy of Artemis provided an updated critique not just of the Space Launch System rocket, but also the Orion capsule, the chosen orbit, the use of Gateway, the lander, and the challenge of refueling, concerns echoed by Destin of Smarter Everyday. Just this week, Eric Berger calls for the cancellation of Gateway and Block 1B. Former NASA Associate Administrator Thomas Zurbuchen points out that China is surging ahead of the US, and Daniel Vergano at Scientific American calls for the cancellation of the Space Launch System and Orion. On October 17, Michael Bloomberg added his voice calling the Artemis program a colossal waste. And a section of this piece was anonymously quoted on X. Which reminds me, the Space Launch System is so weak and Orion is so heavy that they can't even do what Apollo 8 did, fly to a low lunar orbit and return to Earth. Instead, to put a band-aid over the fact that their extremely expensive rocket is not capable of doing the one thing it was meant to do, NASA has added additional cost and complexity to the critical path, in the form of a space station that orbits the Moon, known as the Gateway to some and Tollbooth to others. This thing has more interfaces than the Internet. This gateway ignores 3 decades of hard lessons from the International Space Station to build an expensive, complicated, and not very robust modular space station in deep space so that the Space Launch System has somewhere to go. Gateway's case is so uncompelling that even NASA's internal technical justification just kind of trails off. Of course, getting to lunar orbit is not the hard part. The hard part is getting from the surface of the Moon back to Earth, but under the Space Launch System program these critical requirements are mere afterthoughts. The entire Space Launch System-based Artemis program is an iterated game of whoops, we forgot that, spend another $20 billion for an inadequate fix. A few years ago, NASA announced the Human Landing System program, wildly late and underfunded for such a critical technology. Of 3 proposals, only SpaceX's "would you like a Starship with that" had enough thrust to return astronauts to Earth and, to the surprise of many, was selected. Of course, if you can fly a Starship to and from the surface of the Moon, you can easily put humans and their cargo on board, relegating the Space Launch System, Orion, and Gateway to a mission component that is completely unnecessary, even as it consumes 97% of the budget. Is it really so radical to say that we'd all be better off without it? These BAT charts show the relative complexity and capability of a Space Launch System-based and Starship-based lunar landing system. It's actually a $4.1 billion rocket thrown in the ocean after a single use. The Space Launch System can't work without Orion, Gateway, and Starship. Starship works without any of the other parts. Here I've fixed NASA's 2023 budget request diagram by deleting all the missions that have already been cancelled or are about to be, plus all the parts you don't need to transport humans and cargo to and from the Moon. I've also added question marks next to all the parts you do need to transport humans to and from the Moon that remain UN architected, unfunded, and stand approximately zero chance of being delivered on anything like the proposed schedule. After all, if it took NASA 20 years and $100 billion to build the easy parts of the system so badly that they don't work, how long and how much will it take to build the hard parts of the system so they do work? This is what I mean about corruption of technical integrity. NASA's inability to specify or justify a physically possible architecture for crewed lunar exploration, their constant failures with contracting, their disinterest in holding any contractor accountable, and continuing insistence that everything is fine, rots the organization from the inside out. Anyone and everyone can easily see that the wheels came off years ago. I'm not just talking about SpaceX fanboys and disgruntled former employees here. Every time I write a blog on this topic, I get dozens of unsolicited inbound emails from current NASA employees effectively imprisoned within these programs confirming, and then exceeding, my worst fears. Even people on NASA's payroll working on these programs know it's total nonsense, and yet agency policy compels them to continue to go through the motions, year after year, assembling slideshows of increasingly pathetic renderings and haplessly signing over performance bonuses worth hundreds of millions of dollars to contractors who will probably never deliver. Space is not the place that rewards this kind of approach, and the inexorable fractally catastrophic development of the Space Launch System and Orion tells us everything we need to know. I know this blog is read by honest officials at NASA and in the executive. It's easy enough to confirm what I write is true, it's documented in the agency's own writing. Gone are the days when NASA could back up 1,000 dump trucks full of cash into a handful of private contractors and pretend everything is okay. China is on the cusp of mastering booster landing, eroding the USA's relative advantage. The Chinese space program is hell-bent on landing taikonauts on the Moon, and something tells me that their program managers fear the consequences of failure more than ours do. To ask the question is to answer it, the matter speaks for itself. For how many more years should the US taxpayer continue to fork $5 billion, 25% of NASA's budget, into this unaccountable black hole? Does anyone seriously advocate that the best course of action in dealing with this ravenous consumer of resources and morale is to keep shoveling generational wealth into it slavering more? How many more decades of waste will alter the laws of physics enough to make the Space Launch System a good idea? Cancel the Space Launch System. Cancel Orion. Cancel Gateway. Cancel the launch tower. Cancel the engines. If the contractors squeal, investigate exactly how they managed to spend so much money for so long and still deliver trash. We can get to the bottom of this if we choose to. Is it enough to merely lift the boot of the Space Launch System from NASA's neck? NASA cannot succeed until fact-based reality supplants political expediency as the agency's guiding star. Here is a radical prescription to restore NASA's ability to deliver value to the US taxpayer. Measure and reward productivity. Pay people, promote people, and fire people. NASA today is unable to pay competitive wages, unwilling to promote and reward competence, and unable to remove poor performers. Solve for the equilibrium, and it's a miracle it gets anything done at all. I have an unpublishable blog post documenting all the times. In 4 years at NASA JPL, I personally was punished for making the cardinal error of committing to writing ways I had found to save significant sums of money or time in the schedule. It's a subjective observation, but at the same time, the entire organization was unable to retain young ambitious talent, unable to remove underperformers, and as the record shows, unable to deliver missions remotely on time and budget. It seems crazy that any organization would be so aggressively disinterested in improving productivity, or even slowing its decline, but it is a common failure mode, particularly of large bureaucratic organizations. In private industry, they eventually go bankrupt, but the government can always print more money. Stop blaming Congress for mandating bad programs. Grow a spine. How is Congress meant to know what's a good idea in space? NASA's mission is both niche and esoteric. NASA's leadership needs to advocate for missions that advance its interests, and policies that continually improve its competence to deliver. The last 2 decades of rolling over in the face of Congress's bullying over what has become the Space Launch System has delivered nothing but cascading failure, failing missions, failing leaders, and failing resolve to explore the universe. If NASA's leadership is unable to prevail upon Congress to stop accelerating the destruction of their agency, i.e. do their jobs, they should resign in favor of leaders who can. In the coming months, a new administration will formulate a new space policy. If you're in line to be NASA administrator, the most significant bit, 0 or 1, defining your tenure will be your ability to excise this malignant growth from the face of US space exploration. Nothing else matters in comparison. Either you lead NASA beyond the Space Launch System or you do not lead at all. Let's take a leaf out of Elon Musk's principles for effective tech program management. Why Elon? Among other attributes, Elon's companies have established a reputation for producing value across a variety of hard tech industries where dozens of others, even ones begun by veterans of his own companies, have failed. A full analysis of this is beyond the scope of this post, but his principles for program management are a good place to start, and diagnostic of the failures of the Space Launch System program in comparison to SpaceX's workhorse Falcon rocket, which has now managed 388 launches despite starting development years after the Space Launch System and many decades after the Space Launch System's recycled components. Step 1. Make your requirements less dumb. A sustainable human lunar exploration program needs the ability to move thousands of tons of cargo and people to and from the moon. That's all. In contrast, the Space Launch System, which can transport precisely nothing to the moon, was driven by a requirement that it be built out of spare parts from the shuttle program, itself an incredibly expensive and dangerous rocket to nowhere in particular. Step 2. Delete any part or process you can. The modern reusable Starship-based lunar program deletes the necessity for multiple space vehicles, the Gateway space station, the overweight Orion capsule of the faulty heat shield, and the underpowered Space Launch System, retaining only 2 vehicles, the reusable Super Heavy booster and the reusable Starship upper stage, which can fly to the moon from low Earth orbit and back without refueling. In contrast, the Space Launch System lunar program deleted the Advanced Orion Service Module, crew safety, the ability to carry a lunar lander, budgetary and schedule constraints, effective program management and oversight, and the possibility of mission success. It retained only the parts possessing political protection irrespective of their non-existent utility. Step 3. Simplify or optimize the design. Starship and similar architectures seek simplicity through first principles analysis, adaptation of existing successful designs, adoption wherever possible of standard processes and materials, and aggressive adoption of labor, weight, and cost-saving technology such as modern computers. The success of this approach at SpaceX speaks for itself, with the company launching about 10 times more mass than the rest of the world combined over the last year, and at the lowest launch cost in history. In contrast, the Space Launch System sought simplicity and reliability by reusing flight-proven parts of the shuttle stack, apparently missing the important fact that the shuttle parts themselves were still dangerous despite decades of development. The whole point of the Space Launch System was that it would take only a few years of work to integrate these parts, preserving the supply chain and a few industry jobs in key congressional districts. In reality, it took far longer and cost far more than redesigning the whole rocket from scratch, and delivered a product that is so uncompelling it barely exists, having launched only once in the last 25 years, and at a marginal cost, for $0.1 billion, that far exceeds the total development cost, $3 billion, of Starship to date. Step 4. Accelerate cycle time. The key to efficient development is rapid iteration over incremental improvements. This is how the Apollo program was run, but by the time the shuttle was developed, a much slower model of development had taken over at NASA, in which risk-averse engineering managers spent decades in analysis paralysis, attriting hard-won practical expertise far faster than theoretical analysis could grow knowledge. The Space Launch System continues this theme, with Office of Inspector General reports repeatedly finding that Boeing lacks workers with necessary skills to build the rocket, even as SpaceX has rapidly developed an effective workforce of thousands at the end of the Earth in Boca Chica, Texas. Every 6 months or so, SpaceX will surge operations at each of its key development centers in order to find and fix productivity bottlenecks, and now routinely builds enormous advanced rockets faster than regulators can keep up. Meanwhile, Artemis II is scheduled for no earlier than September 2025, and that's not counting the critical failure of Orion's heat shield. If the Space Launch System launches humans on Orion before the end of 2026, I'll eat my hat. Fast iteration, the Space Launch System has never been. Step 5. Automate. The purpose of the SpaceX Starship is ultimately to move the transport of matter in space below the API. To render it as routine as ordering a box of pencils on Amazon, only this time they're arriving on a moon base. SpaceX's relentless innovation over the last 22 years has pointed the way for the industry towards a reality where rocket launches are as normal as a jet flight. For reference, there are about 45,000 daily commercial flights in the US, while we're on track for about 100 space launches this year, almost all of them by SpaceX. In contrast, despite Artemis II being mostly hardware complete as of July this year, with all major components present at the Cape, it's still not going to launch for at least 16 months, likely far longer, on a program that is costing $12 million per day. Where is the urgency? The only thing that's automatic about the Space Launch System program is the ever-expanding budget, ever-ballooning scope, ever-lengthening list of excuses, ever-slipping schedule, and ever-lacking accountability for this ongoing divergence between dreams and reality. It is tempting to think that summary cancellation of the Space Launch System, Orion, and Gateway would destroy the very fabric of space exploration in the US. On the contrary, it would free up enormous resources to work on programs that A, matter and B, can succeed. It would signal to the aerospace industry and to the world that NASA was, after a long hiatus, once again open for business. An organization connected to and committed to reality. The roots of this transformation are already in place, ready to blossom once given a chance. AI technology, Mars and Titan drones, and the Human Landing System program point the way to the future. How so? The Human Landing System program is a sneaky restart of the entire Artemis program. It's been obvious for a decade that the Space Launch System isn't going to be able to launch even the Orion capsule to the low lunar orbit required to land, leaving a negative margin for a lunar lander, even one as lightweight and unsustainably incapable as the Apollo lunar lander. By soliciting bids for a lunar lander, the Human Landing System program is asking the correct question: how do we get people and cargo to the surface of the moon and back? Starship and Blue Origin's lander represent architectures that can actually deliver this outcome, and crucially neither of them depend on the Space Launch System, Orion, or Gateway. Cancelling the Space Launch System will restore hope to this dying agency, crushed by creeping bureaucratic incapacity, but by rights the crown jewel of US technological and scientific mastery.